So as we continue with solving systems, there are multiple ways, or there are more than one way to solve a system of equations. And when we have a system, with at least one equation that can be quickly solved for a variable, it's often easier to use substitution to solve that system. And our goal is, we're going to be exposed to three different main ways to solve a system, and just being able to recognize the things that make it easier for us to solve. So as we go into the substitution method, what we're going to be doing is we're going to be substituting equal values in order to solve these systems. So if you notice here, as we go into the first example, what is the solution of this system? And they want you to use substitution. Well, we have y equals 2x plus 7 and y equals x minus 1. Well, many ways to look at this. This equals equals y, and this equals y. So therefore, those two things equal themselves. So you could rewrite this as 2x plus 7 equals y, and then of course we know that y equals x minus 1, so really what we have is 2x plus 7 equals, right, equals y equals x minus 1. So that's a way to think about it. And you can also look at it and say, well, if I'm going to substitute in for y, if I know that this equals y, then there's no reason why I can't substitute it in right here. We get the same thing. We get x minus 1 equals 2x plus 7. X minus 1 is now equal to, because we substituted it in for y, 2x plus 7. Again, we're just substituting equal values, and it doesn't matter which one of these two sets of equations you solve. It's the same equation. So we'll just go ahead and continue here. So in order to solve, we need to combine like terms. And I'm going to go ahead and subtract 7 from both sides to zero that out. So I'm going to end up having 2x is going to be equal to x minus 8. I'm going to go ahead and continue to combine like terms. I'm going to move my variable over to the other side. So it turns out that I have x, 2x minus 1x is x is going to be equal to negative 8. Now, just because we know that x is equal to negative 8 doesn't solve our system. What we need to do is we need to go back, we need to look at the equation that we originally started with, and we need to do some substitution. So if we know that x equals negative 8, that means we can substitute that back into one of our original equations and find out what y is going to be equal to. So in doing so, I'm going to have 2 times negative 8 plus 7 is equal to y. Doing some multiplication and combining like terms, I have negative 16 plus 7 is equal to y, or y is going to be equal to negative 9. And so now I'm going to have a xy coordinate. So my solution here is going to be negative 8, negative 9. Okay, so now continuing on, solving for a variable and using substitution. Well, right here we don't have a simple setup as we did before. What we are looking at is two equations in standard form, and we can solve easily for a variable. It looks like I could isolate the x in that term very easily. Now, if I do any isolation in this one, it's going to possibly create some fractions we're not looking for. So if I go ahead and just isolate x in this second equation, I will go ahead and subtract 3y to both sides. And there I have now isolated x. X is going to be equal to negative 3y minus 7. So I'm able to do this substitution because I can take the value of x and I can substitute it in right there into the other equation. So I know that 6y is 6y plus 5 times x, and this is where I'm going to do my substitution. Negative 3y minus 7 equals 8. Now, I can't remember if I really expressly said it, but the reason that we do a system and we solve and do some substitutions here is because when we start this original equation, we have two variables and we can't solve for two variables at one time. So we need to do some way to get to just one variable. So that's why we're going to substitute the value of x for values of y. And then going and substituting that in, it turns out now that I only have y as a variable. So I can solve this for y. So I'm going to go ahead and do my distribution here. So I'm going to have 6y plus 5 times negative 3y plus 5 times negative 7 equals 8. Showing you the distribution so we don't get lost in that multiplication. 6y plus, I guess, negative or minus 15y minus 35 equals 8. Combine like terms. I have negative 9y minus 35 equals 8. Go ahead and add 35 to both sides. And I have 9y, negative 9y is going to be equal to, is that what, 43? So we end up going ahead and dividing by the coefficient, divide both sides by negative 9. And it turns out that y is going to be equal to 43, negative 43 over 9. And of course, you can rewrite that as negative 43 over 9. And that is also equal to negative 43 over 9. All of those are equivalent fractions, just written with the negative sign in a different location. And now that we have the value of y, we are able to go ahead and substitute it back into one of our equations to get the value of x. And what I can do is take this equation right here, and I'm going to have x plus 3 times the new value of y, which is negative 43 over 9, equals 7. I was looking at the wrong problem. Do some multiplication here, and I can even do some canceling before I do that, but x plus, 3 over 9 cancels out to 1/3, so that would be negative 43 over 3 equals 7. Go ahead and add 43 over 3. 43 over 3 to both sides. And I have x is going to be equal to, I'm going to have to go back and fix some of this because that was negative 7, negative 7. So then I have negative 7 adding to 43 over 3. Well, I need to convert this into a fraction. So let's just move this part over here. And so negative 7 becomes negative 21 over 3 plus 43 over 3. And that combined together becomes 22 over 3, or we could also call that 7 1/3. Okay, so talking about what the solution of this system is, where I have 7x minus 3y equals 2, and negative 2y plus x equals negative 6. Well, remember, when we're using substitution, we're looking for a variable that is, isolated or is easily isolated to solve for, so we can do our substitution. It looks like that x is by itself, so we did some inverse operations. We moved 2y over to the other side, so it turns out that we have x is equal to 2y minus 6, so we can go ahead and do this substitution. We can take the value of x and substitute it in here, and we're going to end up then with 7 times that value. So we have 7 times 2y minus 6 minus 3y is going to be equal to 2. And of course, we're going to go ahead and do our distributive property, do some multiplication. And that's going to end up being 7 times 2y is going to be 14y, minus 7 times 6 is 42, minus 3y equals 2. And we can combine like terms. We have our variables that we can combine here. So that turns out to be 14 minus 3, which is going to be 11y. 11y minus 42 is going to be equal to 2. Go ahead and add 42 to both sides. And I'm going to have 44 over here, and I'm going to have 11y over here. Divide by the coefficient, dividing both sides by 11. Y is going to be equal to 4. Now that I have found y, I can go ahead and plug it back in over here if I want. Either problem, it doesn't matter. But if I have negative 2 times 4, because 4 is what y is equal to, plus x equals negative 6, I have negative 8 plus x equals negative 6. Go ahead and add 8 to both sides, and x is going to be equal to 2. And I may not have done the check on the last problem, but so let's see here. If we have, our solution is 2, 4, and I go ahead and plug it into either one of these. I can go ahead and say negative 2 times 4, using my original equation right here. Negative 2 times 4 plus 2 equals negative 6, so I have negative 8 plus 2 equals negative 6, and sure enough, negative 6 equals negative 6. So yeah, this solution does check. Remember, there's multiple ways to solve a system of equation, and we started off with graphing, and we will continue on, and we will learn elimination too. But recognizing some of the things that make each one of them easier to work, and that's the reason we become proficient in math, is to always solve the simplest means necessary. And of course, it wouldn't be algebra without, having a word problem in here. So using systems of equations. You pay $22 to rent 6 video games. The store charges $4 for new games and $2 for older games. How many games did you rent? Now, so we need to assign some variables here because we have 2 different types of games. We also know that, we have new games, we have old games. And what I'll do to make it simple, and I'm just going to call the new games X, and I'm going to call the old games Y. Using XY isn't going to kill us. So let's see here. So 6 games. The games that I rented here, right, they could have been new games or old games. I just know that I rented 6 games, and I know that it cost $22. So what I could do is I could say, well, my new games plus my old games equaled 6 because I rented 6 games. And then I also know that, well, my new games cost me $4 and my old games cost me $2. So, and I know that I spent $22. So then I can go ahead and say, well, shoot, 4x, $4, 4x plus 2y is going to be equal to $22. And what I've done is I like to say that I've kept my apples with my apples and my oranges with my oranges. So right here, I was talking about quantity. So the quantity of new games plus the quantity of old games is going to equal the quantity of the total games. And then now we're talking about money here in this next equation. So the new games are going to cost me $4. So it's 4 times new games plus 2 times the old games will equal $22 because that's how much I spent there. So you can isolate and take this first equation and do some easy isolation. And what I'm going to do is I'm going to isolate for y just because I don't think we've started an equation that way and there was no reason not to. So I have x plus y is equal to 6. So I'm going to go ahead and move x over to the other side. I know that y is going to be equal to negative x plus 6. And now I can substitute in. I have a value of y that I can do some substitutions. So I'm going to have 4x plus 2 times negative x plus 6 equals 22. Do some distribution here. You have 4x minus 2x. Remember your distribution because I'm multiplying by everything in the parentheses. Negative 2x plus 12 is going to be equal to 22. Again, do some combining like terms right there. So I have 2x plus 12 is equal to 22. Using my inverse operations to combine like terms, get my numbers over to the other side. I'm going to go ahead and subtract 12 from both sides. And then I'm going to have 2x is going to be equal to 10. Dividing by the coefficient to isolate my x, I have x is equal to 5. So it looks like I rented 5 new games. Now, if I rented 5 new games, right here, do some substitution. X plus y equals 6. Well, if x is 5, 5 plus y equals 6. Well, I think we can probably figure that one out without doing too much math, but y equals 1. So I could have rented 5 new games and 1 old game. That's the context, right? 5 and 1, 5 new video games and 1 old video game is how much are the quantities of games that I rented, and that's what they're asking me. How many games did you rent? Well, technically I rented 6, but they wanted to know what type of those games that I rented. And continuing on with systems of infinite and many solutions. So we're talking about special solutions. Graphs. When we have 2 different graphs or 2 different equations, and they have they're either going to intersect or they're not going to intersect. So if they have the same slope, they're not going to intersect. I'm sorry, they may not intersect. The same slope, the same slope, but different y-intercepts, they will never intersect. If they have different slopes, they will intersect at some point in time. And if they have the same slope and the same y-intercept, they intersect infinite many times because they're going to be on top of each other. So if I solve these, and what I'll do is I'm going to do B first because that seems to be the easiest problem here. So I've already solved for, or I have isolated, I have variables here by itself. Y has already been isolated. So I can just do some substitution. I'm going to take and I'm going to plug in the value of y for this thing right here. And in doing so, that's going to give me 3x minus 11 minus 3x equals negative 13. Now I'm going to go ahead, the parentheses aren't important here, and I'm going to go ahead and drop them and combine like terms. So I have 3x minus 3x, so that's going to give me 0x, okay? So those two cancel each other out, and then I'm going to have negative 11 is equal to negative 13. Well, that is not a true statement. It does make for no solution. There's no solution because it's never true. So we have a no solution item. That not true statement. And if we come back over here to one that we have to do a little bit more math on, if we do that, we can go ahead and do some isolation and combining like terms. And I'm not sure which one is the most convenient way for others to go, but let's see. To avoid this decimal, what I'm going to do is I'm going to go ahead and solve up here. I am going to go ahead and solve for, I guess it really doesn't matter. I'm going to solve for y. So solving for y, I have 6y plus 5x equals 8. And I'm going to go ahead and move everything over to the other side to get y by itself. And that's going to cancel that out. I'm going to have 6y is equal to negative 5x plus 8. So go ahead and divide everything by 6. And y is going to be equal to negative 5 over 6x plus 4/3. And I can do some substitution for y now. I have a value for y. So that would give me 2.5x plus 3 times negative 5 over 6x plus 4/3 is going to be equal to 4. Oh goodness, that's a lot here. Let's see. 2.5x plus negative 15 over 6x plus 12 over 3 is equal to 4. Now we know that this is going to simplify down to 4 over 1. This is going to simplify down to 5 over 2. So in doing that, I'm going to have 2.5x minus 5 halves x plus 4 equals 4. Well, I'll tell you, if you don't see it, right here we have 2.5 and then we have negative 5 halves, which is also 2.5. So those two things become 0. And I have 4 is equal to 4, and that's a true statement. So that is going to be infinite. I guess I should spell it right. infinitely many solutions. So there you go. If it's a true statement, it's infinite solutions. If it's not a true statement, it's no solutions.